Good afternoon. In the previous session, we are discussing about the testing the overall significance of the sample regression, that is the null hypothesis. Testing null hypothesis beta 2 equal to beta 3 equal to 0, and the also we have discussed the analysis of variance approach to testing the overall significance of an observed multiple regression, that is applying F test. We have discussed what is meant by TSS and RSS and explained sum of squares. Also the analysis of variance table for 2 variable and 3 variable. Now let us go further. So once the analysis of variance table is prepared, the next step is to taking the concluding part, that is decision part. So this is how the decision rule is there. So decision rule of the F statistic. The null hypothesis H naught equal to sigma 1 squared equal to sigma 2 squared. Then alternative hypothesis sigma 1 squared is greater than sigma 2 squared. Then the critical region, if this ratio is greater than, the calculated ratio is greater than critical value of F, then we reject the null hypothesis. Similarly, in case of sigma 1 squared equal to sigma 2 squared, alternative hypothesis sigma 1 squared is not equal to sigma 2 squared. The first one is the one-sided hypothesis, second is the two-sided hypothesis. In such case also, if the variance ratios is greater than the critical value, that is calculated variance ratio is greater than the table value, we reject the null hypothesis at the considered level of significance. Here sigma 1 squared and sigma 2 squared are the two population variances. Similarly, S1 squared and S2 squared are the sample variances. So NDF is there. See, NDF and N alpha by 2. Alpha by 2 two-sided hypothesis. Therefore, if alpha is equal to the level of significance equal to 5% level, that is 0.05, then alpha by 2 is equal to 0.025. So I have to refer the table in the column 0.025. NDF is the NDF and DDF denote the numerator and denominator degrees of freedom respectively. Next, ANOVA table for the child mortality example. I have considered the result I have taken from the book itself, of course. The example, the results of the child mortality. This first column is source of variation, degree sum of squares, degrees of freedom, and mean sum of squares. Sum of source of variation. Two are there. One is due to regressors, means explained sum of squares. Then due to residuals, that is raw residual sum of squares or error sum of squares. So sum of squares values are given. So here the values are 2,50,362.4. That is for the regression due to regression, and the sum of square due to residuals or errors equal to 1,06,315.6. Degrees of freedom is 2 and 61. Total is 63. Now 2,50,362.4 divided by 2. So with respective degrees of freedom, if we divide this, we get the mean sum of squares. So here, mean sum of squares for due to regression is 1,28,681.2. Similarly, due to residuals or disturbance error term is 1,742.88. Now F equal to this ESS divided by RSS. Let us see further. See then f statistic, the statistic f equal to mean sum of squares of explained sum of squares divided by mean sum of squares of this is residual sum of squares or disturbance sum of squares, that is equal to, the ratio is here 1,28,681.2 divided by 1,742.88, that gives you 73.8325. Once if you obtain the f value, then it is not completed, it is not finished. Then the next step is to take up the conclusion. So without conclusion it is incomplete. So how to conclude? So to conclude we should have some base. So what the base? The critical value. Critical value, it is obtained from the respective table. So for the given level of significance, I have taken for both level, that is 1% level and 5% level. See, critical value of f means stable value of f for 2 and 61. 2 is the numerator and 61 is the denominator of degrees of freedom. 0.05 means that is the level of significance equal to 5% level equal to 3.15. Similarly, critical value of f, that is also obtained from the table. You have to refer the table and get the values. So go to there and for the numerator 2 and denominator 61 for 1% level, that is 0.01, alpha equal to 0.01. This is 4.98. Now how to conclude this? This is the critical value is the table value, and what you have calculated, actually computed value f statistic with the ratio, that is 73.83, that is the calculated value. If calculated value is greater than tabulated value, here already greater, so far greater, because 73 is far greater than 3.15 and 4.98. So in both the cases we reject the hypothesis, reject the null hypothesis at 5% level of significance and also 1% level of significance. That means that there is no significant difference between the two population variances, that is both population variances are not equal. This is the procedure of concluding. Next is an important relation between r square and f. See, there is an intimate relationship between coefficient of determination of r square, that is r square, and f test used in the analysis of variance. To test the null hypothesis, say beta 2 equal to beta 3 equal to 0, we have seen that f equal to, so explained sum of square divided by its degrees of freedom and residual sum of square divided by its degrees of freedom is distributed as f distribution for 2 degrees and n minus 3 degrees of freedom. So in general, for k variable case, so including intercept, we assume that the disturbances are normally distributed and that the null hypothesis is say in general. So where are beta 2 equal to beta 3 etc. beta k, and beta 1 is the intercept term, therefore it is not included in this, and it follows that f equal to, the f statistic equal to, here explained sum of square divided by the k minus 1. If k equal to 100, then k minus 1 equal to 99, and RSS equal to n minus k, number of observations of due to regressors, number of regressors. It should be greater than k. So n minus k, total minus total degrees of freedom, minus the number of regressors, that is equal to n minus k. It follows the f distribution with k minus 1 and n minus k degrees of freedom. Note that the total number of parameters to be estimated is k, of which 1 is the intercept term. Then the relation between r squared and f may be written as, that is for, this is for the k variable cases we have considered so far, but same is, you can take the relationship between the r squared and f. On the basis of that we manipulate this f test like this. Then the relation between f squared and f may be written as, I have taken the final value. The proof is not necessary for you, only this formula is enough. So in the MCQ also they may ask those questions. The relation between r squared and f may be f. So you have to choose the formula out of the given. So you should know the formula also. That is why I have taken this, the relation between r squared and f. R squared is the coefficient of determination. So where r squared f equal to r squared divided by k minus 1 divided by 1 minus r squared divided by n minus k, where r squared equal to explicit sum of square divided by residual sum of square, are the disturbance sum of square, error sum of squares, and r square. And when r squared equal to 0, what happens? If r squared equal to 0 means numerator is 0, then numerator is 0 means then f equal to 0. When r squared equal to 1, what happens? R squared equal to 1, so f is infinite. So division by 0 becomes meaningless, or that is infinity. Thus f statistic, which is a measure of estimated regression, is also a test of significance of r squared. Instead of testing the previous formula, you can test the r squared also. This is another method. In other words, testing the null hypothesis that beta 2 equal to beta 2 equal to beta 2 equal to 0 is equal to testing the null hypothesis that population for the population coefficient of regression equal to r squared equal to 0. That is also same thing. So let us stop here. Thank you. Have a nice day.